Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, and the problem is my calendar 1. You are implementing a program to use as your calendar. We can add a new event if adding the event will not cause a double booking. It should not be redundant. A double booking happens when two events have some non-empty intersection, that is, some moment is common to both events. The event can be represented as a pair of integers start and end that represents a booking on half open interval start and end. End is not included. If it is 5 to 20, then it is included one. The included in it is the included intervals are 5 to 19 only. 20 is not included. And the range of real numbers x such that the start less than or equal to x less than end. So implement the my calendar class. My calendar initializes the calendar object, and boolean book function returns true if the event can be added to the calendar successfully without causing double booking. So if it causes double booking, we should return false, else we should return true. That's what this function defines. And this is the example. Let us take the example and work out, so that we will get a clear idea. So this is our input, and first the calendar my calendar object is created. Then 10 20 we have to check whether this 10 to 20 interval is booked. Still this 10 to 20 is not yet booked, so we will book this 10 to 20, which means 10 is occupied, 11 is occupied, 12 is occupied, 13 is occupied, 14 is occupied. Similarly 15, 16, 17, 18 and 19. 20 is not occupied. This is, they have given that start is less than or equal to x and x is less than end. So till 19 only. So 10 to 19, this all consider this as tickets. So these tickets are booked. So next comes so we have to just return true, since everything are just booked only once. We have to return true. Next 15 to 25. Let us in similar way we will try to book this 15 to 25. Let us take this 15 itself. 15 is already booked. You can see here this 15 is already booked. So we have to return false. So we will not be booking further any seats. Next we can try to book 20 to 30. Similarly, we will see 20 is booked or not. 20 is not booked, so we will book 20. Next 21, it will go till 30, so it will go 21, then 22, then 23. 24 is also not booked. 25 is not booked. 26, 27, 28, 29, 30 we will not be booking. We will be booking till 20 to 29. So we will book all the seats, all the tickets till 20 to 29. So then we will be returning true. So this is what the question is. If we are booking first time, then we have to book all the seats till end, and then we will be returning true, or else we will be returning false. We will not be booking anything. So what will be the brute force approach? If there is an interval, what we can do is, if there is an interval, we will book all the tickets from the start till end minus 1. End is 20, 20 minus 1 is 19. So 10 to 19 we will be booking all the seats. We will try to book all the seats. If we are able to book all the seats only once, then we will just return true, or else if there is a conflict occurs, consider we are booking this 10 to 19, then we are given with the interval 9 to 12. Then what we will be doing is, we will try to book 9, then we will be trying to book 10. Then while trying to book 10, this 10 is already booked, so we cannot book this event. So what we will be saying is, this 10 is already booked, so we will be returning false. So we should not do double booking. So this 9 is also not booked there, since it is returning false. So we will remove this. So this will be the brute force approach. We will try to book all the numbers, and then we will check whether this all is booked. If it is all is booked, then we will return true, or else we will return false. So the data structure that we can use here is, we can use a map here, since we want to know whether this is booked or not. So how we can say is, we can have a map, and first we will try to book all the, we will try to check whether all start to n minus 1 is booked or not. If all start to n minus 1 is not booked, that is not present in the map, we will be booking this is not present in the map. Then what we will be doing is we will book all the tickets from start to n minus 1, then we will return true. If we can come across that some other some one any one ticket which is present in already in the map, then we will just return false. So this will be the brute force approach. Hope I made clear. Will be the use brute force approach will be giving time limit exceeded, since we will be running linearly for all the tickets. If it is ranging from 10 to 20, then we will be running from 10 to 20. So it will be costly when the test cases are increasing and the numbers are very large. So how we can optimize this approach? Let us take this interval 10 to 20. We know that this 10 to 20 is already booked. Already booked in the sense this 10 to 20 is the first booking that we are doing. So next we will be having an interval. We are having an interval 15 to 25. So this 15 to 25 is merging with this 20 to 20, right? This 15 is in between this 10 to 20. So we are saying that we are returning false, since this 15 to 25 is already booked. 15 to 25 some seats are already booked. So there will be only two cases. Either 10 to 20 means either the incoming interval, can be greater than this 20 to that is 22 to something, we can say it as 30, or else we can say it as before this 4 to 5. So this will be the interval. These are the intervals that is not going to do double booking. If we found this intervals which are not double booking, then we will be returning true. So that's what the intuition arises here. If we are having an interval, if this is the first interval, then we will add this to our map, or else we will check whether the current interval is already conflicting with the intervals that are present in the map or not. Let us say like this. We are having an interval which is 22 to 25. First we'll be inserting this 10 to 20 in our map. Then we are having this 20 to 25. And now when we are encountering this 20 to 25, we have to check whether this 22 is conflicting here with this interval that is present in the map. What we can say is, if this 22 is greater than this 20, we can say that it is not going to conflict at all, because this 22 I will be less than this end point. This is the start and this is the end. This is the start and this is the end. 25 is the end. So this 20 start will be less than this end always. If the start is going to be greater than this end of this interval, then we can say this is not going to conflict at all. So we will go to the next interval and check. So what I'm coming to say is, if we consider this as start 1, this as start 2, this as end 1, and if this is start 2 and this is end 2, then what we can say is, if my start 2 is greater than end 1, we can just continue. We don't want to do anything, because this is not going to make a double booking at all. Or else if there is a case like 4 and 5, 4 and 5, 4 and 6, let us say take this as example. If we are having this 4 and 6, what we'll be saying is, since this 4 is less than this end interval, that is start 2 is less than this end 1. Since the start 2 is less than the end 1, we have to check whether this end 2 is not conflicting, that is end 2 is not in between this range. If this end 2 is lesser than the start one, then we can say this 4 and 6 is does go for 4 and 6 is does not making a double booking. That is 4 and 6 is not going to merge with this 10 and 20. If there is 11 here, consider we are having 11, the end 2 is greater than this start 1. Since this end 2 is greater than the start 1, this 4 and 11 is going to make a double booking. So we will be saying that this is a double booking, so that we will be returning false. So what we are doing here is, if the start 2 is less than this end 1, and we are going to check another condition, which is end 2 is greater than the start 1. If this is the case, if this S2 is less than E1, if this S2 is less than E1 and this E2 is greater than S1, then we will just return false. Or else we will be returning true. If this is not conflicting with any of the intervals that is present in our map, then we will be returning true. So this is what the logic we are going to implement here. So first we will be having a map. Let us declare our map, private map. We are going to store a pair of integers start and end, so we can say it as int comma int map. Inside this constructor we will clear the map. Once it is cleared, we will be first we will initialize this start and end as int start2 is equal to start and end2 is equal to end. And another we will initialize two variables, s1 and e1. S1 and e1 is nothing but the intervals which are in the map. Auto pair and frequency, we don't want this frequency. We are iterating this map only, that's what we are doing here. The syntax is here. So this s1 is nothing but p dot first, and this e1 end1 is nothing but p dot second. So we will just copy this case itself. If my start 2 is greater than my, if my start 2 is less than my end 1, and if my end 2 is greater than my s1, then what we can say is we can just return false, since it is conflicting. Double booking, it makes a double booking. Or else what we can say is we can just return true once we find. Before returning true, we have to add this particular interval start and end to our in a map, so that we will be doing for next iterations. We'll be updating our intervals in our next iterations. So we can run our code and see. Yeah, it got accepted. Let us submit the code. The time complexity here will be order of n into n. For n intervals, we will be iterating the map and checking whether this is this is conflicting or not. So it will be n square. And hope you understand this video, understand the problem. Let us solve the tomorrow's LeetCode daily challenge. Until then, bye.